Welcome back. Today we're going to work on Lesson 5, which is solving problems by finding equivalent ratios. Our I can statement is I can use tape diagrams to find an equivalent ratio when given the part-to-part ratio and the difference between these two quantities. So our keywords I want to look at is that tape diagrams. So remember, a tape diagram is just when we use a model to represent a problem, and it uses what we call a tape or a model made up of different square lengths. So this would be a tape model, and then our other keyword is again using that equivalent ratio. So equivalent meaning equal, so equal ratio. So 2 to 3 is a ratio. That is equivalent to 4 to 6. If you don't remember, check our previous lessons. Remember, when we're working with ratios also, ratios compare two things. So the two things it can compare is what's called either a part-to-part, and that's what we'll be working on today when we have two parts of a whole and we compare them. So let's look at our first problem. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks at the local DMV, or Department of Motor Vehicles. The DMV reported that in the month of August, for every 5 passenger cars registered, there were 7 pickup trucks registered. How many of each type of vehicle were registered in the county in the month of August? So this is our ultimate question. How many were registered? So how many pickup trucks and how many cars were registered? And it's telling us that's a 7 pickup truck to 5 car ratio. But before we get to that, let's work on this portion just to remind ourselves. Use the information in this problem, write 4 different ratios, and describe the mean of each. Well, one ratio is going to be comparing our cars, so 5 cars to 7 trucks. That's one ratio. Our other ratio can be, we just flip trucks and cars. So I have 7 trucks and 5 cars. They're not the same ratio. Remember, ratios, the order is important. They're ordered pair. So here I'm comparing cars first to trucks. Here I'm comparing trucks to cars. So these are 2 different ratios. These are part-to-part comparisons. What that means is we're comparing one part of the whole to another part. Our second thing is called a whole-to-whole comparison. So here I'm comparing 5 cars to the total number, which is trucks and cars, or my total vehicles. I can write one more ratio where I compare my trucks part to the total vehicles. These ones are called what's called part to whole. I'm comparing part of the problem, trucks, to the whole entire problem, which is my trucks and cars. So now we're ready to start the problem it was asking us. But before we do, let's watch this short video.
What are equivalent ratios? To help us picture equivalent ratios, let's take a look at an example. Let's say that Michelle is pulling weeds from her garden. In 1 hour, she pulls 64 weeds, 48 of which are dandelions. Let's also say that Eric is helping her. In 1 hour, he pulls 96 weeds, 72 of which are dandelions. Now let's create ratios of dandelions to weeds. Let's take a look at each person's ratio. First, we'll take a look at Michelle's. According to our problem, Michelle pulls 64 weeds, 48 of which are dandelions. And we want to write this as a ratio of dandelions to weeds. That means we have 48 dandelions to 64 weeds. Just like that. Now what about Eric's ratio? Let's take a look at that. According to our problem, we would have this ratio. 72 dandelions to 96 weeds. Now to get an even better picture of these ratios, let's write them as fractions. So Michelle's fraction would be 48 over 64. And Eric's fraction would be 72 over 96. Great. Now if we took a look at these ratios, They don't look like they're the same at all. But in order to see if ratios have the same value, we need to reduce each of them to their simplest form, then compare them that way. So let's reduce. In this fraction between 48 and 64, the greatest common factor is 16. So we divide by 16 in the numerator and the denominator. And we get the fraction 3/4. Now we take a look here. Here we can divide this by 24 over 24 in order to reduce it. And we get the fraction 3/4. Now look! When we reduced each of these fractions, we got 3/4 in both cases. 3/4 and 3/4 are definitely the same. They have the same value. That means that these two fractions also have the same value. And they are called equivalent ratios. Equivalent ratios are two ratios that have the same value. So here, because we reduced each of these fractions and saw that they have the same simplified form, that means that they have the same value. That means that they're equivalent ratios. So here, we have 3/4 is equal to 3/4. Now let's rewrite each of these as the original fractions that they were. That means that we will have 48 over 64 equal to 72 over 96. These two fractions or ratios have the same value, so we can set them equal to each other. If we have equivalent ratios, we can set up a proportion like this. And proportions are very helpful when we're trying to solve problems. Now, how can we tell if two fractions are equivalent? Well, let's see. To figure out if two fractions or two ratios are equivalent, we need to do exactly what we did in step 1. Simplify each of the ratios that we're dealing with and see if we have the same value. If we do, that means that we have equivalent ratios. So let's take a look at another example. Let's say we have 9 over 12 and 21 over 24. To see if we have equivalent ratios, we need to reduce each of these fractions to its simplest form and then compare them to see if they're the same. Here, to simplify, we divide by 3 over 3, and we get the fraction 3/4. To reduce this fraction, we divide by 3 over 3, and we get the fraction 7/8. Now, is 3/4 the same as 7/8? No, it's not. 3/4 is not equal to 7/8. Since these fractions do not have the same value, that means the original fractions do not have the same value either, which means that these are not equivalent ratios. So now we know, in order to have equivalent ratios, we need to have two ratios that have the same value, just like this. In order to tell if we have equivalent ratios, we need to reduce each of the fractions to their simplest form and compare them. If they have the same value, then we have equivalent ratios.
All right, so now we're going to look at how we can make models to find equivalent ratios. So what I'm going to do is, it's asking me to make a tape diagram that represents the quantities in the part-to-part ratios, not part to total or the whole that you wrote. So let's look back at our original problem. What is it asking us for? Well, it's asking us for a ratio of 5 passenger cars to 7 pickups. So that's going to be our problem that we're going to make. So how do I do this? Well, what I'm going to do is it's telling me there's 5 cars, so there's 1 box, 2 boxes, 3 boxes, 4 boxes, 5 boxes. And then how many trucks were there? Well, there were 7. It was a 5 to 7 ratio. So my trucks are going to be slightly longer. There's my 5, and then 7 more would be 6, 7. So here I have my ratio of 5 to 7. Now, think of this. How many equal-sized parts does the tape diagram consist of? Well, it's 12. I have 1, 2, 3, 4, 5 for the car, 6, 7, 8, 9, 10, 11, 12. So my tape diagram is 12 equal parts. So what's the total quantity that the tape diagram represents? Well, remember from that original problem, it's telling me that there were 192 total cars with a ratio of 7:5. So my whole entire tape diagram is going to equal 192. But what I need to know is how many cars there are and how many trucks. So let's look at this part. What value does each individual part of the tape diagram represent? Well, I know the whole entire thing is 12 boxes. And of those 12 boxes, I have 192 vehicles. So what I need to do is I need to figure out how much each box equals. I need to break them up into equal groups. So how am I going to do that? Well, I'm going to divide 192 divided by 12. What is that? Well, when I divide 192 by 12, remember this top number is inside that box, and I divide by 12, and what I get is 16. So here's my next part. How many cars and trucks are there of each? Well, what does this 16 tell me? That tells me that each box is 16. So this is a 16, 16, 16, 16, 16. And what do I need to do with this? Well, that's a 16 as well for each of the trucks. So now I have two methods that I can now work with. I can either add 16 each time, or I know that my multiplication is just repeated addition. So for my cars, I can do 16 times 5, which will give me 80. So I have 80 cars. And my trucks, there's 1, 2, 3, 4, 5, 6, 7. So I'm doing 16 times 7, and that's going to give me 112. So my final answer is there are 80 cars and 112 trucks. But let's look at it this way just to make sure. I'm going to do another problem. This one, I think we're good. We're going to extend on it. So my new problem is now for the month of September, for every 14 trucks registered, there were 5 cars registered. There were 180 more trucks than cars. How many of each type of vehicle is registered during the month of September? Well, let's look right here. It's telling me that there's 14 trucks that are registered, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 trucks. There's 5 cars. 1, 2, 3, 4, 5. So here is my tape diagram of 14 to 5. So let's look at this question now. These 9 sections represent the more than cars, which is 108. If I look right up here, it's telling me that there are 108 more trucks than cars. So that means there's more trucks than there are cars, and this is how many more trucks there are than those cars. And what is that total amount? Well, it's telling me it's 108. So what I need to determine is how many cars, that should say how many vehicles each section represents. So what I need to do is I need to divide 108, that's this extra part, by 9. Where I got that 9 from is there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 sections. These 9 sections are the more than trucks. So what I'm doing is I'm dividing 108 by that 9. And when I do that, I'm going to get 12. Therefore, each section of the tape diagram represents 12. So, what do I need to do next? Well, I just found out that each section represents 12. And what do I notice about this section compared with this section? Or this section compared with this section? Well, I should notice that they're all the same length. They're all the same size. When they're all the same size, that means that they all are the same. So each section is going to be 12. What do I do next? Well, now I can just count up 12, 24, 36, 48, 60, or I can check and do 5 times 12, which is 60. So there's 60 cars. How many trucks are there? Well, that's 12 times 14, or if I really wanted, I could just do 12 plus 12 plus 12 plus 12. That's going to take too long, or at least I think it will. So I'm just going to multiply out, and I get 168 trucks. Just to check, look, our numbers match, 168 and 60. So we're actually already almost at the end of our lesson. So what you're going to do is, I would like you to log on to Socrative. You're going to try these with a partner if you're on the computer. So with a partner, you're going to do number 1, number 2. Please try those with a partner. When you're done, make sure you put your answers in Socrative. Then, with a partner, this says different. If you're on the computer, you're actually going to use the same partner. You can actually do it by yourself. I'm sorry. You could do it with a partner by yourself. You're going to answer this number 1 and number 2. They will appear as number 3 and number 4, though, on Socrative. It's not going to tell you if the answers are right or not, though. All right. So now that you're ready, you may log on to Socrative. Please try number 1. And please try number 2. And then please try number 3 and number 4. It's not going to tell if you got it right or wrong. So when you're done, please follow these directions. So after you've done Socrative number 1, 2, 3, and 4, it won't tell if you're right or wrong. Please go to AAAmath.com. You're going to click on ratios, and then click on ratios again. Your goal is to get 50 correct with 90% accuracy. After you have accomplished that, please go to Khan Academy. And then once Khan Academy is completed today means you've done 3 sections. Then you may go to math games or typing games. All right, good luck, and I will come and check on you if it looks like you're struggling with Socrative.